So this is part 223. It's line 19a3 Isotropic Quadratic form Anisotropic spaces Wow Seti. Okay. So this is the alien radio signal with the Google math equation with it. And this looks like this is just going to be data, just so you know. I'm researching these words. I don't know what they mean. So relation with classification of quadratic forms. From the point of view of classification of quadratic forms, anisotropic spaces are the basic building blocks for quadratic spaces of arbitrary dimensions. For a general field F, classification of anisotropic quadratic forms is a non-trivial problem. By contrast, the isotropic forms are usually much easier to handle. It's from Wikipedia. And some more from it. So isotropic quadratic form, I wanted to know what it meant, so I googled it. And it says in mathematics, a quadratic form over a field F is said to be isotropic if there is a non-zero vector on which it evaluates to zero. Otherwise, the quadratic form is anisotropic. More precisely, if Q is a quadratic form on a vector space V over F, then a non-zero vector V of V is said to be isotropic if this equation, I can't talk tonight, quadratic form is isotropic if and only if there exists a non-zero isotropic vector for the quadratic form. Oh, okay, so it's giving an example, and I'm sure you guys know what this means. Okay, well, I guess this is a short video. Real short, 2 minutes. Okay, suppose that BQ is quadratic space and W is a subspace, and W is called an isotropic subspace of V. Some vector is isotropic, a totally isotropic subspace. If all vectors are in it are isotropic, then an anisotropic subspace. If it does not contain any non-zero isotropic vectors, I have no idea what that means. I'm lost. The isotropy index of a quadratic space is the maximum of the dimensions of the totally isotropic subspaces. Okay, we're done that video.